Okay, so I'm going to write the topic in here, that is solving systems by elimination. And I'm going to place it on the top so you can see it better, okay, in here. Then in the example one, okay, we are going to solve the example one, but later I read the theory with you. I only write this, okay. Another method for solving system of equations is elimination. Like substitution, the goal of elimination is to get one equation that has only one variable. Remember that any equation stays balanced if you can add equal amounts to both sides. We have one system to consider, but this is only one example, so we move to the theory. I'm only reading this to you so you can understand the idea of the method, but it's better when I solve the exercise with you. Okay. When you use elimination method to solve a system of linear equations, align all like terms in the equations, then determine whether any like terms can be eliminated because they have opposite coefficients. Okay, so for the first part, if we are solving systems of equations by elimination, I'm going to read with you the steps. In the step one, we need to write the system so that like terms are aligned. In the step two, we eliminate one of the variables and solve for the other variable. In the step three, we substitute the value of the variable into one of the original equations and solve for the other variable. In the step four, we write the equations from steps 2 and 3 and the order pair x, y, and check. Again, when you find the possible answer, we need to check. We are going to prove the values that we obtained in the original equation to see if this is going to fit and the statement is true or not. So in the example one, elimination using addition, we need to solve this system. We have something like this: x minus 2 times y equal negative 19. And for the other one, we have that 5x plus 2y equal 1. Okay. If I solve this by elimination, what is the step one? Okay, I'm going to write this step by step. Step one, write the system so that like terms are aligned. So I'm going to write the terms one variable below the another. We already have in order this, but I'm going to write it again so you can see it. 2y equal negative 19. And for the other one, we have 5x plus 2y equal 1. Okay, so I am only going to move in here. You can see that it's completely aligned in here. The variable x with the variable x, y with the variable y, and the numbers that doesn't have a variable, they are aligned in vertical form. In the step 2, we add the equations to eliminate y, and later we simplify and solve for x. Why for y? Because you have one with negative sign and the other has a positive sign. So if you add this, they are going to eliminate. X plus 5x is going to be 6x. 2y plus negative 2y is going to be 0. I'm going to write the 0 in here. Plus 0. And this is going to be equal the number that you obtain when you solve this sum. Negative 19 plus 1 is negative 18. Now what is the only step we need to do in the step 3? Okay, no, we solved in the step 2. I think that it was like in the other method that we only write the step 2 to replace and later we solve. But in here, in this step 2, that is this one, you solve everything. You solve until you find the value for x. So if you have that 6x equal negative 18, you have this 6x equal negative 18, then you only pass the 6 that is multiplying in here to divide to the other side of the equation. So if x is this, you have negative 18 over 6. And you obtain the value for x that is equal negative 3. Okay. We have the step 3. What are we going to do in the step 3? We can read the right part we have. We write one of the original equations and we substitute the negative 3 for x. We already obtained the first value for x, so we are going to replace in the original equations. In what equation can I replace faster? For example, I can use the first one, because in the first one you don't have the x multiplying any number, so when you replace that x is negative 3, you can do it faster. So write one of the original equations. This is x minus 2y equal negative 19. And we replace for x. X is negative 3, so negative 3 minus negative 2 times y. In this case, remember, I already have the value for x, so I'm going to use this to find the value of y. So minus 2y equal negative 19. The number 3 is in subtraction. I'm going to pass it to the other side to add. So I have that negative 2y is equal negative 16. Because I passed the 3 to add, and when you have negative 19 plus 3, you obtain negative 16. So I'm going to erase this because you already know that. Then the other number that I have that is multiplying my variable y is the number 2. It's negative, so I'm going to pass it to the other side to divide with the negative sign. Y is equal negative 16 divided by negative 2. Negative 16 divided by negative 2. And what number do we have? That y is equal positive 8, because you divide and negative divided by negative is going to be a positive. And now I can write in the step 4 the ordered pair. The ordered pair that I have is negative 3 for x and 8 for y. And what else can I do when I have the possible answer? I'm going to replace these values in the original equations and prove if this is the solution, okay, for the system of equations. So if I write in here to substitute in here, and I have the two equations. I have x minus 2 times y equal negative 19, and I have the other one that is x minus 2 times y, 5x plus 2y equal 1. Then I replace the two values. The two values I have for the variables. In the first one, x is negative 3, so I have negative 3 minus 2y. And what number I'm going to replace by y? 8, right? This is equal negative 19. And for the other one, what I'm going to do? 5 multiplied by the value of x, that is negative 3, plus 2 multiplied by the value of y, that is 8. And this has to be equal 1. So you already know the answer. Negative 3 minus 16. We have this in this one equal negative 19. And for the other one, we have negative 15 x is negative 3, and for the other one, y we have 2. Yes, okay. So we have 2 times 8, and here is 16. 2 times y, yes. In here is negative, but in here is positive, so plus 16. This has to be equal 1. Okay. 5x plus 2y equal 1, and I'm only checking that if I copy this correctly. Okay, so 5x plus, I substitute, the first one is negative 3 plus y is 8, this has to be equal 1. Yes, so if I check, when we subtract 16 minus 15, I obtain 1, and in here I obtain the same number. 19 and 19 in this other place. So we can say that the order pair is a solution. The order pair is a solution for the system of equations. Okay. Remember, if we find, for example, that it's correct for one equation but not for the other one, then it's not going to be a solution for the system of equations. But in this case that I proved in both equations and I obtained the same result, then you can say that the order pair is a solution for the system of equations because it's going to complete both equations. Okay. So in the example 2, we need to use elimination by subtraction. In the example 2, we have elimination by subtraction. And remember, we are going to have something completely similar. We have the system of equations. In this part, the first number is 3 with the variable x plus 4y equal 18. And for the other one is negative 2x plus 4y equal 8. Okay, negative 2x 4y. Okay, if I solve this by elimination, remember I need to order this. I need to keep it in that way that you can subtract or add in the variable, okay? In this case, it's easier to eliminate 4y. You can see that you have the same 4y and 4y. What can I do to eliminate one of them? Multiply by negative 1. So when you change the sign, multiplying by negative 1, you are going to have one positive and one negative. What I'm going to write all the steps. Tell me.
You write 19 and it's 18.
18, sorry. Thank you for telling me. 18.
Okay.
Okay. So in the step 1, we write again the equation. Notice that both equations contain 4y, and I write it in this form, one below the another one, 3x plus 4y, this is equal 18, and in the other one we have negative 2x plus 4y equal 8. And what can I do in here? We add the opposite of each term in the second equation. It's like we have to multiply by negative 1 in here. Imagine that I multiply by negative 1 because I changed the sign. They are asking you to use the opposite signs. So if, for example, I change this, but I need to write this in the step 2. Okay, no, in the same step 1 they use it. This is not going to be negative now, it's going to be positive. This was positive, it's negative. Sorry, this is negative. And this is positive, so now I have negative 8. This is what we do, we invert the signs, but we need to invert the signs for all the terms, not for only the 4y, for all of them, okay? And when we add, I only solved this part of the addition and we finish, I think. The step 2, 3 plus 2 is going to be 5x and plus 0. Why 0? Because 4y minus 4y is going to be 0. And in here I obtain that 18 minus 8 is 10. So you say that 5x is going to be equal 10, and you have that x equal 2, because we divided 10 by 5. This is going to be equal 2. Okay, until this part, the important is that you understand that I need to eliminate one variable because I only want to work with one of them. Once I obtain the value for the first variable, in this case I obtain for x, you can obtain for y first if you want. I obtain this, then I'm going to use this value to replace it into the original, into one of the original equations, this one or this one, the value of x, and I'm going to isolate for the value of y. Okay, I think that we are going to finish tomorrow then because we don't have time to finish this one. But try to finish it, okay? Try to finish the exercise, finding the value for y. This is the only step that is remaining, the value for y, and later you prove if the solution is true or not, okay? If it's going to fit for both equations. Okay, so I'm going to stop the recording.